Okay, for this week, the question you need to do tutorial 7, you can see on the screen. So let me pass this to you. Okay, then you can at least see the question. Here's a few questions we need to do. Okay, maybe next time we do tutorial. And then the second part is show you the slide, which I already show you I actually send the WhatsApp introduction to Fourier series already. So we can take a look of that slide there. And then, okay, then I'm going to show you how to actually deal with a Fourier series in general. So what you see on the right hand side is the general formula for Fourier series. Okay, what you see on the right hand side here, this is the general formula for Fourier series. It's slightly different from the even or odd function. Now this general one, where k is any number, right? So this is general formula. I'm going to show you slowly, step by step, how to use actually for even function. Okay, even function. For even function, you can actually use this formula. Okay, use this formula for even function. And you notice that the formula is slightly different. All of them has 4 here. For even function, a0 and an are bn are all 0, but an 4 there, 4 over t, right? And then for odd function, you get all the an 0, bn also has a 4 over t there. So this is slightly different from the general formula. For the general formula is 2 over t, right? You can see the formula slightly different. Okay, so we are going to do example 5. So you need to copy this solution, example 5 here. So this one, the function is ft equal t squared. So this is a function. So you must use this function here to do calculation. And the period is actually 2 pi. From pi, minus pi to pi, so period, this interval is actually t equal to 2 pi. Okay, every 2 pi it repeat. Okay, means every 2 pi repeat. Okay, every 2 pi second means every 2 pi second pattern repeat. So what does it mean? Okay, let's try to draw the picture for you. So I'm going to draw the picture for you here. So this is a function, your t here, and this is a y here, ft, right? So what does it look like from minus pi to pi? So from minus pi to pi, so I mean, let's draw here. So minus pi here, pi here. So let's see when t equals 0, when t equals 0, ft equals 0, right? So when t equals 0, ft is 0 squared. When t equals to pi, then ft equals pi squared. Let's say this is a pi square here. Okay. Let's say this is pi square here. Okay, pi square here. I use a red color one. Pi square. So this is pi square here now. Okay, so when t equals minus pi, you square it, you also get pi square. So the graph, if you draw it, becomes something like this. Okay, if you draw it, becomes something like pi square here, right? So we can draw it here. Okay, this is one period. Okay, t equal to 2 pi. Every 2 pi repeat. So what does it mean? It means that you can draw here, 2 pi here, 3 pi here. So this is another 2 pi here. Distance is t, another 2 pi now. Every 2 pi, the pattern repeat. Okay, if you draw it here, every 2 pi, the pattern repeat. That's from here to here, also 2 pi. Okay, so this from here to here is 2 pi. Now, let's pay attention to how the point look like. Notice that there's an equal sign here. There's an equal sign here. So when you draw it, you must have a solid circle. Solid. Okay, where it is equal to minus pi, you get solid circle. Whereas there's no equal sign on the right hand side, no equal sign, right? So this one, you must have open circle. Okay, that's why the solid, even when you have equal sign, you have solid circle, and no equal sign, you have an open circle. So first thing, they know this because I was told by the multi-coordinate must stress this. So when you draw the graph, I do this. So now what you do is repeat this pattern every 2 pi. So when repeat this pattern, this solid circle now, okay, this solid circle, when repeat this pattern, this solid circle become here now. So it becomes solid again. And then this open circle, okay, open circle, move to other side, right? Let me draw it again, okay. It's open circle, right? So when you draw it, this open circle move to this side, open circle, okay. Repeat the pattern, open circle, but then this solid circle move also to this side, and so this will be a solid circle now. Okay, move to this point. So repeat the pattern. You can join this pattern here, become like this. Repeat this pattern. So you get this. Okay, draw a nice curve because this one don't look like a straight line. So draw a nice curve. Okay, this is repeat on the left hand side, right hand side, right? You can also repeat on the left hand side here. Let's say this is minus 2 pi and minus 3 pi here. So this period also 2 pi. So you can repeat the pattern. So this solid circle here, move to here. Okay, then this open circle, this original is open, right? Anyway, originally this is open here. So move to here, but actually, because we know that this is also solid later on, so this is also solid here. So now my solid is solid here. Every 2 pi repeat again. So because of transferring the point, therefore actually all the points are actually solid point. Okay, this is how the graph look like. So this is showing you how this function look like when you transfer it, right? And when you see the pattern, what kind of function is this? This is an even function. Why is it even function? Because the graph on the left hand side, it make a reflection, become the graph on the right hand side. Okay, same. This is an even function. Okay, so this is even function. What does it mean? It means that Bn are all 0. Okay, this is even function. So that means that all the Bn are 0 now. When you have even function, don't need to calculate Bn. Okay, do it only calculate. So function is even. So Bn is equal to 0. Okay, being reflection, you can see left hand side, right hand side are equal now. And let's calculate here. I need to know, I don't know period is 2 pi, every 2 pi is repeat itself. So I now calculate omega 0. Omega 0, we have a name for this called angular frequency, all right? Omega 0 here, we have a name for this called angular frequency, which is equal to 2 pi over t. So 2 pi, your t period is 2 pi here. So this is equal to 1. Okay, so when you do calculation, you only need to calculate A0 and AN. You don't need to calculate Bn now. Bn is equal to 0. So automatically, because this is even function, Bn automatically equals 0. Okay, let's try to find A0 first. So because of space here, I'm going to show you how to find. Okay, because you can see that this is even function, right? Even function, you only find An, even function. All the Bn are 0. Okay, even function always with a cosine term. So I take this picture for you so that you have better understanding. I'm going to find the formula for A0 now. Okay, go to the next page to find A0. So I need some space. I'm going to put in insert page here. A0. So what is the formula for A0 for even function? Okay, if you've forgotten, let's look at the formula earlier. So even function A0 is 2 over t. Then from 0 to t over 2 ft, right? So this even function A0 here. So let's find A0 here. This is actually 2 over t. Then 0 to t over 2 ft dt, where t is equal to 2 pi period here. So this is ft equal to t square here, where t is from minus pi to pi. Okay, based on this, so this is actually 2 over 2 pi, then 0 2 pi over 2 ft is t square. So this will give you 1 over pi, integrate to pi, 2 pi over 2 is pi, t square. So this will give you 1 over pi, integrate t square, you get t cubed over 3. Okay, integrate t square, you get t cubed over 3. This is power rule here. Integrate t power n is actually t power n plus 1 or n plus 1. Okay, simple integration formula. Then you put t equal to 0, t equal pi. So you get 1 over pi, put t equal pi, the t pi cube now, over 3. And put t equal to 0, get 0 cube over 3. So you'll find that subtract here, this is 0. Okay, after cancellation, you get pi square over 3. So this is A0. A0 is quite easy formula. Apply the formula for even function. Okay, for all function, the usual formula is 1 over t, but then for even function, it's 2 over t, right? Integrate from 0 to t over 2. This is A0. So look at the solution I presented to you. Okay, first one, the graph. Okay, how to draw the graph. Every 2 pi second repeat the shape of the graph. Okay, then I tell you how to find A0. Okay, so now I'm going to find out what is AN now. And okay, so what is AN here? AN formula. AN will be harder. Take a lot of time to do this AN here. Okay, AN. The formula for AN for even function are for even ft. Here my ft is t squared. T from minus pi to pi. So that period is 2 pi. So the formula for AN is equal to now 4 over t. Okay, this is for even function. 0 to t over 2 ft cosine and omega 0 t dt. This is the formula for finding AN. So t equal to 2 pi. Okay, omega 0 we found earlier is 2 pi over t, which is 1. So the whole question becomes 4 over 2 pi 0, 2 pi over 2, ft is t squared. Okay, and then cosine and omega 0 is 1 and t dt. So integrate this one. Let's see, it is 2 over pi now. 0 to pi. Yeah, integrate 0 to pi cosine and t dt. Okay, cosine 0 to pi, integrate from 0 to pi, t squared cosine and t. Okay, so this your AN or depend on n. There will be a lot of n inside there. So how do you integrate this one? You do this integration, you have to do by part. Okay, by part. So just focus on this part first. Just focus on this part first. You can do by part here. Then multiply by 2 over pi. Okay, so let's try to do by part here. So this messy calculation. So I just focus on t squared cosine and t. So remember, to do by part, you have to do RIATE. Okay, what are the terms there? T squared is considered algebraic. Cosine and t is trigo. Okay, so this is L, A, and T. So your U is going to be A here. So you have U equal to T squared. So U is equal to T squared now. dV is equal to cosine and T. Okay, you have U and t dv cosine nt, right? So the one in front is always the u. So then you look at left hand side, differentiate. The right hand side you integrate. Okay, let me draw and select 2 then, and then I can more space to write here. Okay, so one more space to write here. Integrate. So first differentiate t squared, you get 2t. Okay, differentiate t squared, 2t. And then if you differentiate 2t, you get 2. And then differentiate 2, you get 0. So keep on differentiating until you get 0. Then the right hand side integrating. Okay, cosine nt. How to integrate cosine nt here? Remember the formula. Integrate cosine at is equal to sine at over a. Okay, so integrate cosine at cosine at over a. So this one you're going to get sine n t over n. Let's see whether I got correct or not. Okay, then let me check the formula again. Okay, okay, fine, nt over n, correct. So then integrate again. Okay, integrate sine nt, sine at here, you get minus cosine at, okay, at over a. Okay, introduce a minus sign here. So this will give you minus integrate sine, right? You can negative cosine now. Cosine a is n now, nt. Divide by n again. So it becomes n squared now. Then integrate cosine, you get sine. Together minus sine, you get sine nt now. Over divided by n again, get n cubed. Okay, this is how we do integration by part. Okay, so integration by part is a technique especially useful for Fourier series. Okay, then you draw a downward arrow. Downward arrow. This is a plus sign. Another downward arrow with minus sign. Another downward arrow, plus sign. Then the rest are all zero already. No need to continue. So this, after integration by part, let me follow the pattern. So I want to use the color here. So this thing together with this one and together with plus sign. So you get t squared sine nt over n. And then next term together minus sign, minus 1 plus already. So this will become plus. Okay, so just now was come from yellow term. Next one will be coming from green term now. Still plus sign because minus 1 plus already. So this is actually 2t 2t and then cosine nt over n squared. Okay, become plus sign, become minus, minus become plus, all right? So this one is from green term. Okay, then the last term multiply together. This one become a minus sign now. Multiply the minus sign now. So this is minus multiply together, get 2 sine nt over n cubed. Okay, so this is the third term. And you are going to integrate from 0 to pi. Okay, you're going to integrate from 0 to pi. Okay, so put t equal pi inside there. So put t equal pi, let me see the term. The first term is actually pi square sine n pi over n. Second term, put t equal pi equal 2 pi cosine n pi over n square. Put t equal pi there, get minus 2 sine n pi over n cubed. So this is the first term. Then you put t equal 0. So put t equal 0. Very nice. First term is 0. 0 square is 0. Second term also 0. Third term is 2 sine 0 over n cubed, right? Okay, what are they? So first of all, you must understand the trigo value. Okay, the trigo value means what does it actually sine and pi look like? So one thing about sine and pi here. So we arrange a little bit here. So a bit of trigo. First, sine and pi is always 0. When sine 1 pi, 2 pi, 3 pi, 4 pi are all 0. Okay, and you go to 1, 2, 3, 4. Okay, these are all 0. You press calculator, you can see, verify yourself. So that means that this term is 0. This term is 0. This term also 0. Okay, so sine and pi is equal to 0. Then, how about cosine and pi now? A bit tricky. Okay, cosine and pi depend on whether n is even or odd. Okay, so let me write something about cosine and pi first. So actually, what you have is actually this one. This is your an now. So not an now. Maybe the integral is actually right here. 2 pi over n square cosine n pi. This is not your an. Your an, look at this picture here. An is actually 2 over pi. Okay, then times this integral. So an is equal to, insert this one. An is equal to 2 over pi times this integral. Okay, t squared cosine n pi dt. We find out that this integral is actually equal to 2 pi over n squared cosine n pi. we find out that the integral, we find out that this integral is actually this one. So you can simplify. So this is actually 4 over n squared cosine n pi. This is an. Okay, what is cosine n pi? This is a pattern for cosine, right? First, cosine pi, cosine 3 pi, cosine 5 pi. As long as all multiple of pi, you will get -1. Whereas even number of pi, cosine 2 pi, cosine 4 pi, cosine 6 pi, you always got 1. So in general, we have a pattern for this. Cosine n pi is actually -1 power n. So n is 1, you get pi. So n equals minus 1. Okay? N equals 2, you get 1. N equals 3, you get -1. Okay, so that's why you got this pattern. This cosine n pi is -1 power n. So based on this, you can check, right? N equal 1, what happened? When n equal 2, what happened? N equal 3, what happened? You just change according to this. So this is actually 4 over n squared -1 power n. Okay, cosine n pi is -1 power n. This is how you get the n first. Okay, I'm going to end soon because just to make sure that I have finished this example. I'm going to finish already. So let me write down the formula for Fourier series. All right. So Fourier series has this formula: ft equal t squared. Okay, Fourier series ft. Okay, let me write here. Ft equal to a0 plus summation of n from 1 to infinity an cosine n omega 0t plus bn sine n omega 0t. Okay, this is a Fourier series formula. And we found out that a0 is pi squared over 3. Ft is t squared. And then all the bn are 0. So this is actually summation of a1. So this is summation of a1. Okay, let me write this down. Write this properly first. Summation n equals 1 to infinity an cosine n omega 0 is 1. Okay, this is how it looks like. But what is an? So an, we found out that this is equal to 3 summation of this one. An means 4 times, what is it? 4 over n squared minus 1, right? 4 over n squared minus 1 power n cosine nt. Okay, an is this one. So if we expand out, what does it mean? It means that, okay, like, well, pi squared over 3. Now you put n equal to 1 first. N equal to 1, you get 4 over 1 squared minus 1 power 1 cosine 1t. Okay, expand it. So the n equal to 1. How about n equal to 4 over 2 squared? Okay, n equal to 2 now. Minus 1 power 2 cosine 2t. How about n equal to 3 now? 4 over 3 squared. minus 1 power 3 cosine 3t. You can go on like this. So simplify. This equal to pi square over 3. This is actually minus 1. Minus 4 now. Minus 4 cosine t. Then 4 over 4 is 1. Say minus 1 square is 1, so this is cosine 2t. And next one, the other side come up 4 over 3 cosine 3t. And so on. And this is how the Fourier series look like. Okay, how the Fourier series look like. Oh, you can see this. One pattern is note that this an always decreasing. That means that a1, absolute value of a1 must be greater than absolute value of a2, must be absolute value of a3. See the value getting smaller and smaller. Okay, note that. Okay, the term of an getting smaller and smaller. So this a1, okay, a1 is here. This a1, a2, a3. So the one I have here, this will n equal 2 now, n equal 3. Okay, the term getting smaller and smaller. This is how an look like. So this is going to end already. So next lesson we can do some tutorial question. Okay, what's up to you? Okay, that will be end of this lesson. Thank you very much. So next lesson we'll do some tutorial. So I go for another class already, and then another class coming now. Okay, so I'll stop recording.